Hello everyone, so in this video we are going to solve a question of LeetCode. It is because subsequence is 376 question LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Wiggle subsequence is a sequence where the difference between successive numbers is strictly alternate between positive and negative. The first difference, if one exists, may be either positive or negative. A sequence with one element and a sequence with two non-equal elements are trivially Wiggle sequence. Alright, so let's see. The most important point here is strictly alternate between positive and negative. Alright, so we cannot consider equal elements here. Okay, and we need to find out the length of the longest Wiggle subsequence. Okay, so let's see the first example. In the first example, we have 1, 7, 4, 9, 2, and 5. Alright, and let's make a graph for this so that it must be more clear to you. So let's see, like in this we have 1 here and then we have 7, so 7 will go up, okay, in the graph. Then 4 will come to down somewhat here. Then we have 9, 9 will go up, okay. Then 2 will go down, then 5 will go up somewhat here. Okay, so what we can see is this is increasing, or we can say this is positive, okay. Then this is decreasing, so it's negative, okay. Then again positive, then negative, then positive, okay. Why we are saying positive negative? Because this is 7 and this is 1, so 7 minus 1 is 6, that is positive, and in this case 4 minus 7 is negative, so we are taking is negative. Alright, so let's see. In this example what we can say is we have alternate positive and negative pattern, so we can consider all the elements here. Okay, since we have alternate pattern of positive and negative, so we can say all the numbers are satisfying the condition, so we can return 6 as our answer, as all the elements are satisfying the condition. So we have 6 elements here and all the 6 are satisfying the condition, so we can return 6 from here. Alright, so what we can do is, let's say in this we are returning 6. Alright, so I hope this example is clear to you. Let's see the second example to understand how we can take subsequence here. Okay, so let's see in the second example we have 1, 17, then 5, then 10, then 13, then 15, okay, then 10, then 5, then 16, and then 8. Okay, and let's make a graph for this. So 1 will be here, then 17 will go up, then 5 will come down, then we have 10, okay, this is 10, okay, then we have 13, then we have 15, okay, then 10 will go down, then 5 will again go down, then 16 will go up, then 8 will go down. Okay, so what we can say is this is increasing, then this is decreasing, then these three are consecutively increasing. Okay, these three are consecutively increasing, so we cannot take all three values. Like we need to take only alternate positive and negative. We cannot take consecutive positive values here. Then this will go down and this is also go down. Okay, so what we can say is we can take any one of these three. So let's say we are considering the first one and not taking the remaining two. Similarly in this we are taking the first one and not taking this one. Okay, and this is increasing and this is decreasing, so this is fine. Okay, so what we can say is in this we have one element here. This is the first one we can consider, this is the second one we can consider, this is the third one, okay, this is the fourth one, this is the, or we can say, yeah, this is the fourth one, this is the fifth one, this is the sixth one, and this is the seventh one. So total we have 7 elements here, those are satisfying the conditions. Okay, we have just removed these elements from here, or we can say we are not considering these, so total we have 7 here, so we are returning 7 in this case. Okay, I hope the example is clear to you. We are just considering the alternate pattern of positive and negative values, or we can say the up and down pattern, alternating up and down pattern. Alright, so this is the second example. I hope this is clear to you. Let's understand the approach and how can we approach this question in the optimized way. So let's say we are storing the values in an array, or we can take the values in variables as well. So let's see, let me first clear this. Yeah, so let's say we have two variables here. Okay, so the two variables are, let's say we have up and second one is down. Okay, we have two variables here and we are storing the values in these two variables. Okay, so let's say for the first element it can either go up or it can either go down. So what we can do is we can consider both as well. Okay, there are both possibilities, so we can consider both the values as well. Okay, now next we have up. Okay, the next one we have up, so we will update up with 2, the down will remain same. Okay, now again we have down, the next one we have down. So what we can consider is the previous one must be up, that's why we are getting down. So what we can do is whenever we get down we will just update that down with up plus 1. Okay, so this is down, fifth one is down, this 5 one is down, so we will update this with up plus 1. So this 2 plus 1 is equal to 3 and this will remain same. Okay, now we have up. So whenever we get up, we consider that the previous one must be down. So what we can do is whenever we get up, we will just update up with down plus 1. So this up will update to 3 plus 1, that is equal to 4, and this down will remain same. Now again we get up. So whenever we were getting up, what we were considering that whenever we are getting up, definitely the previous one must be down. Okay, so whenever we were getting up, we were just updating up with down plus 1. Let's update this up with 3 plus 1, it is equal to 4, and this 3 will remain same. Again we are getting up, let's update with down plus 1, so 3 plus 1 is equal to 4, and this will remain same, it is 3. Okay, so we can see here that these three values are same. Why these are same? Because this is strictly increasing. Okay, so we are not considering these two values here. That's why these are same. It means our logic is correct. Alright, so let's see for the next values. This is down. Okay, this is down. Then what we were considering? We are considering that if we are getting down, then the previous one must be up. So what we were doing is we were just updating the down with up plus 1. So let's update down with up plus 1. It is 4 plus 1 is equal to 5, and this up will remain same. Again we are getting down, let's update down with up plus 1, that is 5, and this is 4. Okay, now we are getting up. So when we were getting up, we are just updating down plus 1, so up will be updated to down plus 1, 5 plus 1 is equal to 6, this will remain same. Now we have down, so when we were getting down, we are updating with down up plus 1, so this will be equal to 6 plus 1 is equal to 7, and this will remain same. Okay, now the iteration of the complete array is completed. At the end we get two values. Up is equal to 6 and down is equal to 7. Okay, since we need to return the longest value, so we will be returning the maximum out of this. So maximum out of 6 and 7 is 7. So we are returning 7 from here. Okay, I hope the approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Let's move to the coding part. So yeah, let's take two elements here, int up is equal to 1 and int down is equal to 1. Alright, now let's run the for loop. For int I is equal to 1, I should be less than nums dot size and I plus plus. Okay, we can write one more condition here. If, let's say, if nums dot size is less than 2. Okay, if less than 2 there might be only one element. Let's try to return 1 from here. Okay, so now let's write a few conditions for updating up and down. So what we were doing is, if we were getting the highest value, or we can say we were getting the up here, So what is the condition for up? Let's say this is 7 and this is 1 in the first example. So condition for this is, let's say that is nums, this is nums, then this is I, and this is I minus 1. Okay, this is nums I minus 1. Okay, so similar condition, let's write it here. We are just subtracting both the values and we are getting the positive value. Okay, so what we can write it here, let's say if nums of I is greater than nums of I minus 1, then what we can do is we can update up with down plus 1. Okay, and else if we are getting nums of I, mm, let me write it again. It is num that we are updating up with down plus 1, and in the next condition else if nums of I is less than. Okay, the next condition might be that is 7 and we are going down, so this is 4. In this condition this will come negative. Okay, so or we can say this one is less than this one. So what we can write it here, if nums of I is less than nums of I minus 1, then we can update down with up plus 1. Okay, at the end just return maximum of up and down. Alright, I hope this is fine. Let's just run it. Yeah, it's working fine. Let's just submit it as. Yeah, it's perfectly fine. So let's calculate the time and space complexity of our solution. So time complexity of our solution is big O of n, since we are iterating through all the n elements, and space complexity of our solution is big O of 1, since we are storing constant spaces here. And this is basically the most optimized approach to solve this question. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.